Hello friends, I hope everyone is safe in home. In today's video we will learn uh, economical scheduling of power plants or power stations considering transmission losses. In a previous derivation we have considered a Lagrange's multiplier, and in that we consider that the transmission losses are zero, but practically transmission losses are present. So in this video we'll derive by considering a transmission losses. Active economic scheduling here, considering a transmission losses, considering a effect of a transmission losses. So cost, fuel cost or total generation cost is given by, already we have taken the expression F is P1, P2, so on up to PNG. So you can write that as is equal to 1 to NG C1 and P1. Here C1 is cost of fuel per unit, and P1 is a generation. So equality constraint, already we have discussed the G of P is equal to what? Here in a previous we come to know that we have not considered a transmission losses, so that the demand, total load demand is equal to total generation. But here we have considered the transmission losses, hence PD plus PL is must be equal to total generation equal to 0. So here one term is extra, that we have considered a transmission losses. We know the Lagrange's equation. I will write that L lambda P variables F of P plus lambda G of P. So we know that F of P is dC1 of P divided by dP1 plus lambda. So G of P is what? PD plus PL minus summation of I to 1 Ng to P1. So above equation you can say I have taken here. PD is a total load demand, PL is the transmission losses. So summation of 1 to Ng Pi is a total generation of all power plants. So differentiation of this with the P1, so it will be, see this you can say here, you can write F of P here. So differentiation of this one, dou L by dou P1 is Cp1 plus P1 lambda. Differentiation of partial differentiation of PD is 0 because it's a constant. Dou PL divided by dou P1 minus differentiation of that one is equal to 0. So you can write this as dou Cp1 divided by dou P1 is equal to, so lambda 1 minus dou PL divided by, I have taken in the second term to the right hand side, Now you can write it as a lambda is equal to dou cp1 divided by dou p1. So I have taken this right hand term to left hand side, so it will come to denominator 1 minus dou pl divided by dou p 1. So this factor 1 by 1 minus dou pl divided by dou p1, we call it as a penalty factor. Now we can write this expression as dou fi divided by dou p1 lambda dou pl divided by dou p1 is equal to lambda. So expression of a objective function in a quadratic equation, we know that f is equal to half a p1 square plus bp plus c. So this is a objective function. Then incremental cost, you can say dou cp1 divided by dou p1 is equal to a p1 plus differentiation of this one with respect to p1, it is half a p1 square, differentiation is 2p1. So 2 into 1 by 2, it will be 2 get cancelled, it is a p1 plus b. Differentiation of bp is what? With respect to p, it is a p, plus differentiation of a c with respect to p1 will be, it's treated as a constant, so it is a1 a p1 plus b. I will replace this dou pi divided by dou p1 by this one dou p1 plus lambda dou pl divided by dou p1. So I will replace this dou c1 p1 divided by dou p1 by a p1 plus b lambda, remaining part as it is, dou pl plus dou p1 is equal to lambda. Now we know that expression for pl is summation of, already we have discussed in the previous lectures in a power system to previous subject also, it comes summation of I, summation of j, p1 pi bij and pj. Okay, so after if you expand this transmission loss, it will become, if you consider I as a 1, b1 I, j also 1, then p1. If you consider p as a I as a 2, b2 to p2, plus if you consider p as a 1, sorry, I as a 1 I as a 2, I as a 1, b as a 1 and j as a 2, then it will be 2. So consider, so p, consider I as a 2, j as a 1, so it is 2 1 j. So like this. So if you simplify p1 to p1, it will be 1 on p1 square, b2 to p2 square, like this will come. So after simplifying, you will get this expression as So different 2b1 2p1 p2 plus 2b1 3 p1 p2 p1 p3, like this it will be. So on. After differentiation of this one with respect to p1, we will get summation of j to b I j pj. So I will replace this term in the previous term, this one. I will take this as equation 2. So it becomes a p1 plus b plus lambda summation of j to bij pj is equal to lambda. Now I will expand this one, so it will become a p1 b plus lambda 2b 11 p1 plus lambda. I am expanding this summation, so I is equal to 1 already I have written, j is not equal to 1 nj bij into pj equal to lambda. So simplifying and so on, we will get pi is equal to 1 minus b1. So lambda, simplifying, lambda minus b1 minus lambda 1 j is not equal to 1 ng 2 bij j divided by whole divided by a1 plus 2 lambda b11. It's a bit complicated, but if you go on, if you twice or thrice, if you analyze this, you will get the equation. Remember this equation, I will write once again. Lambda is equal to p1 is equal to lambda minus b1 minus lambda summation of I is equal to 1, but j is not equal to 1 ng 2 bij pj divided by a1 plus 2 lambda b11. Thank you.